In this lecture, we'll be talking about function parameters and arguments. Parameters are identifiers that appear in function declarations, in other words, function prototypes or signatures. Parameters are dummy names that represent the value to be supplied to the function. Arguments, on the other hand, are expressions that appear in function calls. So let's look at an example. We have an add function that takes three parameters, a, b, and c. And we are making a call to that add function from within main, supplying the arguments x, 3, and x times 2. So as you can see, the arguments to the functions can be arbitrary expressions, as in this given example. So the first argument to the function add is a variable x, whose value is 2. So 2 will be copied and passed to add. In the second argument, I am passing a constant value, 3, a constant integer. And as the third argument, I am actually writing an expression which is evaluated before the function call, and its result is passed as an argument, as a value to the add function. In C and C++, all arguments are passed by value, which means that all arguments are evaluated before the function call, and the values of these arguments are passed, are copied to the corresponding parameter. That also means that the changes made to the parameter during the execution of the function do not affect the value of the argument. So let's look at an example. We've got a function f that has three parameters, a, b, and c. And within the function, I am changing the parameter, the value of the parameter a. I'm saying a plus is equal to b times b plus c. So I'm basically changing the value of a by adding the value of the parameters b and c. All right, so let's look at how we make a call to this function f from within main. I have three local variables, x, y, and z. I'm passing x to a, passing y as an argument to b, and passing z as an argument to c. Although we are making a change to the first argument, the first parameter a from within the function f, that change does not affect the value of x in the calling context. And the reason is, again, all parameters by default are passed by value. So let's look at this example. If this is example 14, so here it is. I'm going to put a breakpoint in here and go step by step so that you actually see that the parameters value changes, but the value of the argument in the calling context does not change. So I'm just going to go to terminal here. So, okay, we are basically copying the values of x, y, and z to the parameters a, b, and c. So let's go there. So the value of a is equal to x. Remember, x is 2, y is 3, z is 4. I'm passing x to a, y to b, and z to c. So that's why the values of these parameters when I enter the function is 2, 3, and 4. Now I'm changing the value of a by adding b plus c to it. So a becomes 9 now, and I'm returning this value. So when I come back, when I return from this function, you'll see that the value of the first parameter, a, in the calling context, which was x basically, I was passing the value of x to a, is not going to change. So when I print x, you're still going to see that the value of x is 2. It does not get changed just because I changed the value of the first parameter. Because this is called call by value convention. So you're basically making a copy of this variable, the result of this expression. It's a copy that's being made to the parameter. So uh, that space that a occupies in memory and the space that x occupies are different. So these are different boxes in a sense in memory. So x refers to a different box, a refers to a different box, and when you make this call, you're basically copying what is inside the box that's referred to by x into the box that's referred to by a. That's why when you make changes to a, you're making changes to a different box than what x is referring to. This is called call by value. Let's see what the implications of call by value parameter passing convention is. Assume that we would like to implement a function that takes two integers and swaps their values. Here's a function that supposedly implements this. Here is the swap function that has two parameters, a and b, and I am making use of a temporary variable, TMP, inside the swap function to swap the values of A and B. So I'm basically copying the current value of A to TMP. Then I'm saying A is equal to B, so the value of A is now equal to B. And finally, I'm saying B is equal to TMP. TMP, remember, the TMP contains the original value of A. So these three lines of code actually swap the values of A and B. But the question is, just because you swap the values inside the function, do they get reflected into the caller's context? In main, which is the caller, I have two variables, x and y, with the values of 2 and 5, and I'm calling swap. And when I return from this function, you'll see that the values of x and y do not change, because this is all to do with the pass by value convention. Remember, when we make this function call to swap, the values of x and y are copied into the values of b and c, which are different boxes. So you could again think of x and y being two different boxes in memory where we put 2 and 5. And when we make a call to swap, we now have two different boxes, A and B, where we are basically copying the value of x to A and the value of y into B. So we have now four boxes in memory, one box for A, one box for B, one box for x, and one box for y. So these are different boxes. Just because we are making changes, you're swapping the values A and B, they do not change the value of x and y. And this is all to do with the pass-by value convention of C and C++. The question is, sometimes we really want this. We would like to make it, write the code and make changes inside the function, and we want the changes to be reflected to the caller's context. That is, any changes that we make to the parameter, we want them to change the arguments, the x and y, in this example. So how do we make that possible? Before we go into how we make that possible, let's execute this example 15, just to see that the changes that we make to the parameters do not change the arguments. So let me put a breakpoint in here again, go step by step. This is example 15. So let's come here. Again, look at x and y, 2 and 5. Now I'm going into swap. So A and B now are two different variables, and their values are 2 and 5, because that's what we passed from the original calling context. But think about them. These are separate variables now, and we just copied the values of x and y into A and B. So when we make changes, so TMP is now equal to 2, A is equal to 5, and B is equal to 2. As you can see, we actually swapped the values of A and B. But these do not change the values of the arguments in the calling context. So as you can see, in the caller's context, the value of x and y before I made the call to swap were 2 and 5, and after I returned from swap, they were still 2 and 5. But within the swap, the value of A and B initially were 2 and 5, but after the 3 lines of code that actually swaps these values, they have been 5 and 2. But again, these do not get reflected into the caller's context, changing the arguments. That's not possible. And the reason, again, is the calling convention is what's called call by value. We're just copying the value of these arguments into the parameters. So any changes we make inside the function will not change the value of the arguments. But sometimes we want this, like in this example, we actually want the value of the arguments to get swapped rather than the parameters. So how do we make this possible? So that's what we're going to look at next. Let's first define what a reference variable in C++ is. A reference is an alias or an alternative name for an existing variable. It provides a way to access the same memory location as the original variable, allowing you to manipulate the actual data rather than a copy. So here's an example. We've got a variable x, integer, initialized to 2. Then I am defining what's called a reference variable. The reference variable refx has to have the same type as the original variable. But now, instead of saying integer refx is equal to 0, you put an ampersand in front of the reference variable. So you say integer ampersand reference x is equal to x. Now both x and refx refer to the same memory location. So in a sense, what we did was we defined an alias or an alternative name for this box. So we can refer to it using x or ref x, because this has two names now. Both x and ref x refer to the same location. So now when I print x and ref x, because they refer to the same memory location, this printf will print 2. If I change x, I can now change this box using the first name x. When I change x is equal to 5 and refer to the same box, now you're going to see both x and ref x have the value of 5 because they are both referring to the same box. Or I can change this box using the alternative name. Ref x is equal to 7. Then because I'm changing only this box, both the value of x and ref x would be 7 in this example. So this is example 16. Let's go there. This is how you define it. So this is, I'm defining a variable, integer x, initializing it to 2. And then I am saying integer reference x, so ampersand the variable name ref x is equal to x. Again, if I omit this, then I would be declaring a separate box, separate variable, and copying the value of x into this box. So in that case, because we have two different boxes, any changes that you make to x will only change the box referred to by x, and any changes that you make to ref x would change the box referred to by ref x. So let me first run this thing so that you see that you have now two different boxes, two different memories, two different variables. So initially, because I initialize ref x to x is equal to 2, ref x is equal to 2. When I change the value of x, ref x is not reflected because this is not a reference variable at this point. This is a separate variable. That's why when I make a change to x, only the box referred to by x is changed. Ref x is not changed. And when I later change the value of ref x would not be changed, only ref x would be changed. But that's not what I want. I want to define ref x to be a reference variable by putting an ampersand in front of it. That means now there is only one box referred to x, and ref x is an alternative name for the same memory location. All right, I'm not creating a separate variable. I'm just defining a separate name or an alias for this variable x. All right, so that means if I make changes to x, that also will change the ref x because it's the same box. So let's run this code again, and now you're going to see any changes to x or ref x will change the other variable because they are basically referring to the same memory location, same box in memory. So initially x and ref x is 2. Now I'm changing the value of x. That also changes the value of ref x, and I'm now changing the value of ref x. That changes the value of x. So don't think that these are two separate variables. X and ref x are the same variable. The actual variable is x. Ref x is just an alternative name or an alias or a separate name for the same box for x. So using the concept of a reference variable, we can now rewrite our swap function so that any changes that we make to the parameter actually changes the value of the argument in the calling context. So how can we do that? So instead of defining integer a, integer b, we say integer ampersand a, making a reference variable, and integer ampersand b, making b a reference variable. So from the calling context, from main, we're making call to swap, passing x and y. Because these are reference variables now, a actually refers to the same box that x is referring to. So we are basically, this is called by reference. We are not calling by value. We're basically initializing a to refer to the same box that x is referring to. Similarly, we are making b to refer to the same box that y is referring to. So we are not defining two separate variables in a sense. A is an alias for x, and b is an alias for y. So in memory, there are only two boxes, x and y. A and b are only references. So that means within the function, if I change the value of a or b, these actually change the value of x and y in the calling context. So this is example 17. So let me show you that. I'm going to put a breakpoint in here and go step by step so that you see that as soon as we make a change to a and b, the value of x and y in the calling context will change. So let's go step into the swap function. All right. So let me do X and Y. I don't know if I can do it. Probably not. All right, so let's swap A and B using the 3 lines of code using a temporary variable. Now, when I change these, because like I said, A and B are reference variables, so that means the values of X and Y in the calling context is going to change. So when I return, as you can see, X and Y have also been swapped. And after the swap, so before the swap, the value of X and Y were 2 and 5. After the swap, the value of X and Y are 5 and 2 now. They have also been changed. And this has all to do with the reference variable. So anytime you make any of these parameters a reference variable, this is basically referring to the same variable in the calling context. So this has also some implications as follows. When you have a reference variable like this, you have to pass a variable in here. So I cannot pass 2, for example. This is not possible. 2 is a constant value. So I cannot make a reference refer to a constant value. Constant value does not, allocate a memory location, right? Or similarly, it has to be a variable of the same type. Similarly, I cannot use pass an argument as an expression. So if I do an expression like this, an expression is evaluated and its value needs to be passed to the function. But this is a reference variable, so reference variable cannot refer to a value, right? That's why when you make these reference variables, these have to be variables as well. Now that we have seen two parameter passing conventions in C++, call by value and call by reference, let's look at what the implications are if we pass objects as parameters into functions. So I have a function f1 that takes a string. Remember, strings are not basic data types in C++, but rather objects. So in the first one, I am just saying string str. This is not a reference variable, but it's just a parameter. But in the second function, f2, I'm making str a reference variable. And from within main, I'm first making a call to f1, passing name as the string, and then f2 again passing name. And within f1, I'm just changing all characters of the string to a, and inside f2, I'm changing all characters of the parameter to b. So what happens when you have when you declare it like this in f1, when you say string str, again, the string is passed by value, meaning that a new copy of the string object is going to be made when I make a call to f1. So any changes that I make to string inside this f1 will not get reflected into the calling context, meaning that the name in the calling context in main will not change. But if I pass a reference, as in f2, I'm basically saying str is simply referring to the same object name in the calling context, meaning that a new copy is not made when I make a call to f2. So that means any changes that I make to str inside f2 actually changes the string in the calling context. So this is something that you really have to understand. So here's example 18. I have two functions, f1. In the first one, I'm using call by value convention, meaning that the string, when I make a call to f1, a new copy of the string is going to be made. But in f2, I'm making str a reference variable, meaning that when I make a call to f2, I'm just passing the reference rather than making a new copy of the object. Meaning that also means that if I make changes to str inside f2, these changes will be reflected into the calling context. So let me actually go here step by step. So I'm gonna first make a call to f1. All right, so let's make a call to f1, and you're going to see that str is a completely different object, a completely different string. So any changes that I make in here only changes str, right? As you can see, str has all been a's. But when I return from here and print a, for print name, you see that the value of the name does not change, because when I make a call to f1, a new copy of the string has been made, and that any changes that I make to name inside this f1, I'm only making into a new copy of this object str. But when I call f2, which is the second function, now I'm passing a reference, which means that any changes that I make to the parameter actually changes the name, the string in the calling context. So if I now print it, you can see that name has changed to BBBBB, which is what we did in the in F2. All right. So you have to understand that as soon as you make this a reference variable, you're actually referring to the original object or original variable that's being passed into this function. So any changes that you make to a reference variable within a function will actually change the object or the variable in the calling context. But if you pass an object or a variable by call by value, as in this example, any changes that you make to this object or the variable only changes the local copy within F1, but does not change the actual variable in the calling context. Some last words on reference variables. References must be initialized at the time of creation. So here we are declaring a reference variable y by putting an ampersand in front of the variable and saying is equal to x. So we are making y to refer to the same memory location that x is referring to. So y is an Alice for x. You have to define it like this during the time of creation. So you cannot, after initialization, you cannot change a reference variable. So later on, I cannot say y is equal to z. Although z is a double variable, just like x is, I cannot change this reference later on. This is not possible. All right. Let's just look at one more example before we finish our discussion on reference variables and call by reference. Here is a decompose method that takes a double variable and returns its integer part and its fractional part. So the number itself is called by value, but its integer part and fractional part are reference variables. All right. So here's how I make a call to this function. Within main, I declare a double variable 43.25462, and I'm going to get the integer part of it in I and the fractional part of it into variable f. So I'm making d, I, and f. A copy of d is going to be made into num, but I and f are passed as reference variables into integer part and fractional part. So any changes that I make into integer part and fractional part within this function will actually change the values of I and f. So when I return from this function, I can now print the values of I and f. So let me run this thing before we finish the discussion. So here it is. Let me run this thing. You're going to see that the value of I will be 43 because that's the integer part of it. So that's 43. And the value of f would be whatever the fractional part of this number is. So we are now done with reference variables, call by value, and call by reference conventions in C++. Any questions you might have, please leave them in the comment section.